So exponential functions and models. If you're currently, yeah, because we're behind. If you are currently, guys, if you're currently in Algebra 2 while taking this class, then this will be very helpful for you because it's the unit that we're actually currently in. So it's like double dipping. All right, so we all remember that this is a linear parent function, correct? And that all these attributes of the linear parent function should be familiar. Right? All that looks familiar about a line. Okay. Now we're going to recall the exponential. Why is it this bright of green up there? I don't know. It's way lighter on mine. Here we go. All right. We couldn't. We were told not to. They told us not to the thing. Exponential functions. So, guys, an exponential function, it's a function that's rapidly growing, right? It's either going to be a growth or a decay, something that's changing fairly quickly. When you look here at the exponential function, you can see that the domain of it is all real numbers, correct? So the domain is all real numbers, and the range of an exponential is from 0 to infinity. That's because there is an asymptote. Do you remember that? Horizontal asymptote at y equals 0. Okay. What's graphed right here? This is actually 2 to the x. That's the graph that's being represented. Okay. There is, it's increasing. And in theory, there's no minimum or maximum because it's growing.
You know, the Fannies and bigger than the Fannies?
I'm not pleased. Huh? All right. So if you wanted to, there is a detailed difference between linear and exponentials that you can watch and evaluate. But the main thing in the summary from that video is that linear functions are increasing or decreasing by adding the same amount each time. And exponential functions are increasing or decreasing by multiplying the same amount each time. Okay. If you're dividing, that's multiplying by a fraction, correct? That's why it says multiplying every time. If you are subtracting, that's adding a negative. That's why we only focus on saying adding and multiplying. Okay. Because that also implies subtraction and division. That's the main difference between your linear and your exponential. All right, so we're going to decide here, do the tables represent a linear function or an exponential function? So when we look at table A, how are the y values changing? How did I go from 10 to 7, 7 to 4? I'm subtracting 3 each time. So this makes this a linear function. Does that make sense? When you look at table B, how are the y values changing? You're multiplying by 3 each time, right? So this makes it an exponential function. Okay, does that make sense? So do you see the difference as a table from a linear and an exponential? Yes. All right, good. No questions, comments, concerns? Okay. All right, exponential equation. So exponential equation is when you have y equals a times b to the x. Okay, so to find a, you look for when x equals 0. So your a is going to always be f of 0 equals a. So you're looking for the y-intercept, right? 0, comma a, that's your y-intercept. To find the b, you're going to divide the y values of 2 points just to see how did they change. Okay, that's your ratio, your change factor. And the key thing here, what makes it exponential is that the exponent must be a variable. If the exponent is not a variable, then it's not an exponential function. Questions so far about exponentials? Remember, if something's missing, it should be in your week 13 notes on Brightspace if you need a reference back to or follow along. Good? All right. So here we have, find the values for C and A so that f of x equals C times a to the x satisfies the condition. So it tells us f of 0 equals 6 and f of 1 equals 3. Because we have f of 0 equals 6, in terms of our problem, this is a b to the x. So we know that our C value has to be 6 because that's our initial. So we can already rewrite it as f of x equals 6 times a to the x. Then it gives us an x and a y to substitute in to solve for our a. So for f of x, we are going to substitute in 3, 6 times a, and for x, we're substituting in 1. Because what is x? F of 1, 3. Remember, it's ordered pair.
How's 1x 3 and the other is 1?
This is f of x means y, sweetie.
Oh, yeah, yeah.
On the last slide,
The multiplication symbol? Yeah. Just to emphasize that these two things are being multiplied. All right, what would a have to be? Or what would I need to do to get a by itself? Divide 6, right? So I divide 6 and I get a equals what? 1/2. So now I have my C, I have my a, so I could actually write the function. So f of x equals 6 times the 1/2 to the x power. And that would be the function. Your other option is to look at it or think about it in terms of a table. I have 0 is 6, 1 is 3. How did I go from 6 to 3? I divided by 2, right? And dividing by 2 means you multiplied by a half. Do we see that? Yes, no, maybe so. Okay. So there's the substitution method and there's analyzing how did I go from 0 to 1. And like the previous slide told you, your f of 0 tells you your a. And if you're trying to find your b, divide the y values of 2 points, which is what happens here, right? All right, let's try another one. Yes. All right. So here we have f of -1 equals 1/9 and f of 1 equals 1. So if you need to see it as a table, you're saying you go from -1. At -1, you have 9. We don't know what 0 is. And then at 1, you have 1. So you're trying to figure out what is your C and your A for this problem. Well, you can't just find your C by looking at 0 because do you know 0 yet? No, you don't. So, but you're going to start off with your A. So at least finding your A would be a good place to start. So we said to find, meant finding the A. It says to divide, right? So if I'm dividing 2 points, so I have 1/9 to 1. How did I go from 1/9 to 1? So 1/9 to 1 is being multiplied by 9. And then how did I go from -1 to 1? I multiplied by -1. So based on this logic, what's 9 divided by -1? Well, 9 would have to be 9, right? 9 divided by 2? No, I did that wrong, guys. On the x's, you add and subtract. This is multiplied with this. How do I go from -1 to 1? It's addition or subtraction. You add it 2. There we go. So here we multiply. So our rate would be 9 divided by 2. And what is 9 divided by 2? 9/2, which is 4.5, right? Okay, so then as we're going through this, we would have to figure, okay, well, now we're at 4.5, or that's our A value. So we now know what A is, and you can choose either one of these points to use as your X and your Y to solve for your C. Would you want to work with 1/9? No. So, but if you choose that, hey, am I going to stop you? No, I'm not. I'm not. I'm going to let you work with 1/9. So I'm going to substitute in 1 equals, do I know my C? No. Do I know my A now? Yes, it's 4.5. So following this logic, what would I need to do to get C by itself? It would have been better to keep it as a fraction. 1 divided by 9/2 equals C. How do you divide a fraction? You keep, change, flip. So what does that become?
1 times 9/9.
1 times 2/9. Because you keep, change, flip, flip, flip. 1 times 2/9. You keep the numerator, change the operation, and flip the denominator. And that gives us 2/9 is our C value. Flip, flip, flip. Y'all don't know that song? I'm old. I'm really old. The fact that no one knows what that is anymore. The song, when you say flip, 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 flip.
I didn't know jump.
That's older. Jump is older. That's even older than what I just said.
Well,
So we have f of x.
I know that song.
It's from this Houston rapper named Little Flip.
What the heck?
That's why nobody knows it.
It was pretty big when I was in like 9th grade. So we have 2/9.
That's when music came on YouTube.
Ha 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 ha.